in normal positioning and normal movement, the vertebrae, you can turn right, left, you bend in various directions, and that's what it would look like. And here's an opening where the major nerve roots come through here. Mm-hmm. And we're going to get a little more specific in a moment, but right where I'm pointing here, that's one of the joints. And there's actually 4 joints. There's one here, there would be one attaching to the vertebrae above. So 2 on this side, and then there's another joint on the left side, and then this would attach to the vertebrae above. So it's actually 4 joints that need to move as you're moving. And of course, we move hundreds of times a day typically. What happens, too much muscle pull, too much tension, could be a sudden impact energy, a lot of causes. The vertebrae become compressed too vigorously, too tightly, and the joints where I'm pointing become stuck together. And it limits the mobility. And in real life, these joints, the model doesn't show up, but these joints are surrounded by sensory nerves. A lot of proprioceptors, various other sensory nerves, Meisner's, Merkel's. But what happens is they get irritated when this becomes stuck or jammed like this. And that's part of what causes your pain, discomfort. And also they can send signals to the muscles attaching here and telling the muscles to contract. Here's another model, and this gets a little more focused. And can you see that okay? Mm-hmm. Okay, so what this is representing, and it's not too far from reality, the suction cups represent what we call articular capsules, where 2 bones join together. And what they should be doing is going in and out as you're compressing, turning right, opening a little bit as you turn left, for example. But they compress in and out, they give, and that's why bones don't just slam together or stay stuck together. They have to move as you move, and it would look similar to this suction cup like mobility. Sometimes they get a little sticky, and if you look over to the left side, we just use magnets to represent that they can become a little stuck and not moving too well, and with a little bit of force you can release it and they start moving more freely. Let's shift to this model of 2 suction cups, the same ones. And what happens when they become compressed together with too much adhesive tension, here I'll push these together so you can see that, and now they don't move as freely. If I try to stretch or even give a fair amount of force, they don't want to separate. But if I move them a little bit more like that, the popping sound actually is gas bubbles that were trapped inside making a popping sound with the expansion of movement. So what I'm leading up to is in chiropractic, when the joints that we just talked about on the model represented here become stuck together, where stretching or pulling on the muscles isn't enough to release them, we give a sudden impulse, a force, a proper adjustment, if you will, to release that adhesive-like suction, and then they are joined together in a more proper way, and that restores normal mobility to the area. Now, it also takes that pressure that was happening on the nerves that was irritating the nerves. That pressure is also reduced at the moment of release. Now, you notice how these are actually moving more than they probably move in reality when we're adjusting you, but there's not really a positional change in the vertebrae. There may be a momentary shift of a fraction of an inch, but surrounding muscles and ligaments that this model doesn't show. Okay, the simple rubber band will represent, for example, a ligament. And there's lots and lots of ligaments here. Let's bring this over. Let's see, that looks good. There would be encasing the vertebrae here, some in the front, huge anterior longitudinal ligament. They're everywhere. There's muscles attaching here to here, if you will. So it's very encased in. So when we provide an adjustment, the suction cup adherence releases, but the vertebrae doesn't just go flying back into position any more than it was significantly out of position. It just sort of opens for a moment, releases the compression in here, but the position pretty much stays the same.